Welcome back, class. Today we're doing arc length and area of a sector, and we're going to get back into that unit circle that you guys learned last year. So the first thing you need to know are these two formulas, and they will be provided on your worksheets. Arc length, S, is equal to radius times theta. And then area of a sector is 1/2 radius squared times theta. Now there is a key important piece that has to be noted here. The angle needs to be in radians, because that is a real value. That is key. You cannot do these formulas until the angle is converted into radians. So let's look at these two problems. Find the arc length and the area of a sector. Well, I look, the radius is 3 inches, the angle is pi over 3, that's in radians. So I can use both formulas as they are, and I could say S is equal to the radius, which is 3, times the angle, which is pi over 3. Now with arc length and area, you guys can just give me decimals. We'll do round to 2 for today. So you can literally just type this in your calculator, but if you notice, the 3's cancel and it's pi. So the arc length from here to here, that's what we're finding. We're finding the length of this piece is just 3.14 inches. If we do area, it's just 1/2 r squared theta, and r again is 3, and theta is pi over 3. So if you type that all into your calculator, you get the area of the sector, which again is the shaded red region, is 4.71, and then remember the units for area are square inches, or square whatever you have. Okay? So again, before you do the problem, you have to look at it. So again, number 2 is saying find the arc length and area of the sector. Same thing. However, this angle is not in radians. Need to convert. So need radians. And if you guys remember from yesterday, to convert, if we have degrees, you want radians on top. That would be the conversion. Multiply by pi over 180. And really, you guys could just leave it like that if you wanted to and use this 45 pi over 180 in your calculator, but this does simplify to pi over 4. Now we can do exactly what we did on the last problem. The arc length, excuse me, is the radius, which is 5, times the angle in radians, which is pi over 4. So we get that this arc length here is 3.93 feet. The area of the sector is 1/2 5 squared times pi over 4. And again, I'm not showing you the calculations in the calculator. I assume you guys know how to type in the calculator. 9.82 square feet. Okay, so that is that. Real quick on your homework, they're going to give you blanks. They're going to say, I know that if theta is equal to 1/3 radian, and the arc length is equal to 3, what is the radius? All you do is use the formulas given, so you say 3 is equal to 1/3 times r, and then solve for r. So on your homework, just solve for plug all the information into your formula, and then solve for the missing letter. We also have 2 applications here. Mitch is running a relay race around a circular track, so we have a circle, and is 96 degrees from passing the baton to Kevin. So assume that Mitch is here and Kevin's here. This is 96 degrees. If the radius of the track is 36 meters, how far does he have to run? So you have to decide, am I doing area or arc length? Well, if it's how far you're running along the outside of the circle, so that has to be perimeter or arc length. So I want S. I also need to convert this angle. I need radians. So I'm going to do that first. So I get 96 degrees times pi over 180. Which, again, if you don't simplify it, you can literally just leave it like this for your calculations. It's the same thing. So that's my angle, 96 pi over 180. So the arc length that Mitch has to run is the radius of the track, which is 36, times the angle in radians, which is 96 pi over 180. When you type that in your calculator, you find out that Mitch has to run 60.32 meters. Okay. So again, same type of concept, except for we're just putting some words to it. No big deal. No big deal. Alright, Sarah is painting the inside of a circle for a decoration. However, she wants to paint 135 degrees of the circle. Why, I don't know. Maybe she's trying to do some fancy art thing here. But we have 135 degrees. If the circle has a radius of 5 feet, how much wall will she end up painting? Now again, you have to decide, is this area or arc length? Well, when you're painting inside, that's like shading, that's area. So we want area for this problem. And again, I gave you the angle in degrees. So we need to change the degrees into radians. So you can leave it like that, or again, this simplifies into 3 pi over 4 if you guys remember your unit circle from last year. So now we can just use our area equation. So 1/2 radius is 5 squared. The angle is 3 pi over 4. You type all that in your calculator and you get 29.45. And again, if I'm going fast, again, pause the video while I'm talking and try it on your calculator. You don't have to keep listening. You can pause whenever. That's the beauty of videos. And see if you're getting these numbers right. Alright, so that's arc length and area of a sector. Now we're going to talk about the unit circle. Now the unit circle, again, has every point from the center. The radius of the circle is basically 1. So every point has a radius of 1. So if you remember correctly, if I go from here to here, this point is 1, 0. This point is 0, 1 up here. This point is -1, 0. And this point is 0, -1. Then we have our 3 main reference angles in the unit circle. We have the 30 degree, and if you remember correctly, you have the x value of √3/2, 1/2, for the y value. At 45, you have √2/2, √2/2. Remember, 45 degrees, both the x and the y are the same. And then at the 60 degree, now if you draw like the little triangle here, the x is shorter, the y is longer, so the x is the 1/2, and the y is the √3/2. And what you have to remember here is that the x is cosine and the y is sine, because since the radius is 1, so the coordinates down here are cosine of theta, sine of theta. Alright? The other thing you need to remember is that tangent of theta is just equal to sine of theta over cosine of theta. So before we go on, it's easier to just write the tangents down on the circle. If I do y over x, so remember sine is y over x. Y over x is 0 over 1, so tangent is just 0. Y over x for this one is 1/2 over √3/2, which is 1 over √3. Now, I don't remember if we're going to have you rationalize or not, but if you do, that also turns into √3/3. So that's what it would be. If you divide y and x, since they're the same, you get a tangent of 1. Here, when you divide y by x, the 1/2s the 2's cancel, and you're just left with √3. And then look what happens at 90 degrees. If you do y over x, whenever you divide by a 0, you get undefined. So that's supposed to help you with tangent, just to have that there. And then it kind of follows suit as you go. And remember where things are positive and negative. X's are positive on the right and negative on the left. Y's are positive up and negative down. Tangents are positive in 1 and 3 and negative in 2 and 4. Alright, so here's how you do this. Sine of 30 degrees. Okay? Now, you can look up at the circle up above. But here's what I'd like to do. I'm just going to show you again how I do this. 30 degrees is right here. So I think, which one's bigger, the x or the y? Well, the x is longer at 30 when the y is longer at 60. So that means the y is the shorter piece. And since 30 and 60 always either have 1/2 or √3/2, the shorter piece is 1/2. That's the way I think of it. 45, automatically, reference angle of 45, both the x and the y are √2/2. Okay. 270, first I have to think about where that is. 270 is down here. That point is 1 away from the 0, 0, and it's down. So it's 0, -1, which means that the sine is just -1. I don't need to write that actually. Tangent of 90, we wrote that at the top. At 90 degrees, we have the point 0, 1. Well, tangent is y over x. Well, what does this mean? Hopefully for you guys, it means that it's undefined. Okay. 330, you have to figure out where that is and what the reference is. 330 is almost 360. It has a reference of 30 again. So this is just like the triangle I drew in number 1. At 30, anytime you have a reference angle of 30, the x is √3/2, the y is 1/2. So I know the answer is 1/2, but I have to be careful. What quadrant am I in? Well, in this case, the y is moving downward. So this is actually -1/2. Okay? Now we're going to look at 150. Again, 150 is almost 180. Another reference of 30 degrees. So again, 30 degrees, the x is longer than the y. So this time I'm asking for the x though. Cosine is the x. So I'm going to say √3/2. But again, you have to remember, is x positive or negative going in this direction? And hopefully you guys are thinking, oh, it's negative. I moved to the left. So that means that this answer is actually -√3/2. Now tangent of 210 is probably the trickiest one, because 210, we have to figure out where that is. It's a little more than 180. So that means, again, we have a reference of 30. All these have pretty much references of 30. There's no references of 60. Oh, maybe the next one. So then we look and we say, all right, at references of 30, the x is √3/2, the y is 1/2. Now, if you notice, the x is negative and the y is negative. So tangent is going to be y over x. Whenever we have a 30-degree reference, that gives us, and since the negatives cancel, you get 1/√3, which we can then rationalize to √3/3. So it's positive in quadrant 3. And finally, sine of 240. 240 is 60 degrees past 180. So we have a 60-degree reference for the first time. When you're at a 60-degree reference, the x is shorter than the y. So the y has to be the √3/2, the x is the 1/2. The y is negative because we're going down, so my answer is -√3/2. Okay? I know I quickly flew through this. I was just trying to get you guys back. If you are struggling with doing it that way, I just did it so I didn't have to keep looking back up at my circle on the video. However, you guys are more than welcome to figure out the reference. Remember up here, this is a 30 reference. 30 degree, 45 degree, and then a 60-degree reference. Those are the points you always get. The only difference around the circle is if they're negative or positive. Alright, so that is arc length, area of a sector, and the beginnings of unit circle. Good luck on your homework, and I will see you next time.